Hello, hello, hello. Kevin Epps here, Digital Brilliance Hour with another tutorial. So in this lesson, we're going to go over scripting for a model. So you've had a chance to go through the intro to coding. You've had a chance to start familiarizing yourself with the manual. You've had a chance to at least understand how these codes are written out. You might not understand what they do, but you at least understand how to read them and see what you're actually looking at before you start understanding what they do. In this lesson, we're going to actually slightly go over what these functions do and then apply it to what we want to do. So let's go ahead and get started. So in our case, we have Max here. Max, he has a move in our demo. If you double tap either right or left and hit A immediately after, so for A, so you'll see a little move that he does. So he steps forward a little bit, does his punch, and then steps back. So what I want to do just for this is make him dash forward a little bit. It has some power. Instead of that little quick step that he does, make him like, as he's stepping forward with that punch, have him like glide a little bit. So that's what we're going to do for him. So I'm gonna go ahead and close out of this. So, and thankfully we actually have scripts that do just that are made for that purpose. So if you go to your animation.c file, which is in your scripts folder, your scripts, then animation.c, I actually already have it open. There are a few different movement functions that we have. I'm going to show you how it's currently coded up in the model file, but I want you at least to see what's available in this animation script here. So you have move X. So if we look, just without even reading through this, you should be able to tell that you're going to be moving across the X axis, meaning left and right. So there'll be no up and down. You're moving left and right. So as we're reading through this, number one, the function is called move X. It takes in an integer or a number called V. It also then takes in, it creates an integer called R, which is a random number that has a modulus of 180. Also creates an integer called VX and VZ. So again, we don't have to go into too much depth on what this does. I'm just reading you what it does. So VX, this means, even just reading this, you could tell because it has an X in here, it's going to be dealing with something on the X axis with the Z included in the V. So V is for velocity, the base velocity, as we see here in 370. Z would correspond with any value in relation to the Z axis. So these are what these variables are being declared for. VX is taking this random number between 180, taking the cosine of that angle, because that's basically an angle, taking the cosine of this angle of 180, then multiplying that to the actual velocity that's pushed in here in V, and assigning the value to X, to VX. Same thing with VZ. Whatever that random number is, taking the sine of that angle and multiplying it with the value that's been inputted into this function from this parameter V. We'll multiply that to the sine of the R that's happening, and that'll be VZ. So immediately after that is calling another function, because you can tell that it's another function because it has these two parentheses. So you have inside the parentheses, you have 3 parameters. So that means dasher calls for 3 parameters. So you have Vx, which is being declared here, which is being calculated here. Then you have 0, and then Vz, which is being calculated here in line 376. So there has to be a function called dasher somewhere in here, or available to it somewhere. So let's just scroll down and see if we find anything. Oh, what do you know? So dasher's up here. So this dasher is referring to this function. So this dasher is going to be calling this function. And if we look at this function, we see that void is a void function. Dasher is the name of the function. It has 3 parameters like before. This time, instead of using integers, is using a float. A float is basically a number that includes a decimal. That's what a float is. So float, a Vx, float Vy, float Vz. And in this case, it's taking the get local var, which is self, basically the object that's actually calling this function. So whatever object, in our case, is going to be max. So the max object, that is the self that's being calculated and put into this variable. The direction, this is taking the object of self, getting that entity property of that object. That property is called direction. So it's checking the direction. It's either going left or right. It's either facing left or facing right. So it's just trying to determine what it is. 397 is asking if direction is 0, meaning it's facing left to the left. That also lets you know that the property of direction outputs a number instead of text. So it's not going to say left or right. It's going to say 0 or 1. So if it's outputting 0, if dir is equal to 0, remember this is a conditional. So if dir is equal to 0, if he's facing left, then that means to run this logic here. So basically this is saying if he's facing left, you take the Vx value and make that equal to the negative form of Vx. So you take this Vx value here, the parameter, and make it negative. That's all you're doing. That's only if this self object is facing left. And then at that point, it takes these values that you've done, and now we're going to change the entity property. Change the entity property of self, which was again, this is going to be max, and change the velocity. So the velocity is how fast or slow it's going, or if it's stopped. Then it's going to apply these values. So the Vx is the x value, so left or right values. The z axis, which is the floor, so it kind of moves into the diagonal when it comes to the regular stages. So diagonal value. So if you want to move up or down the floor, that's what Vz does. And then you have Vy, which is your up and down. So that's a jump up and down the y-axis. So it's applying those values that you've put in here, these parameters. If facing left, it's going to make that x value negative, and then applying those to the velocity property. Now, one thing to note, you don't see there's a stop that happens here. So all it's doing is just applying some velocity to an object. That's all it's doing. So we need to figure out if we can stop at some point. You see there's a leap here, so you can make it jump. You can make the object jump. You can make the object jump in a certain direction. Okay, so you have some stops here. So you have stop at 445, at line 445. This just basically, and again, here's the comment here that says stop movement. So it takes self, the get local var of self. You'll see this a lot. getting this the object that is calling this particular script and this function, which will be max. Taking max, changing the entity property of max, and changing the velocity to 0. So that's stopping the movement. So that's basically what it's doing. Then you also have a stop to, where you can actually stop the velocity and stop the speed, but let's just worry about stop for now. But there are many different functions. Again, if you haven't gone through this script file here, this animation script, definitely go through it to see what you have access to. But we're going to use stop, and we're going to use move X for now. All right. So let's go ahead now that we have this, let's go ahead and go back to OpenBORStats and open up max in OpenBORStats. So I actually already have them open. So I'll double click to open them up. And I believe that $A is set to the free special animation. And as you can see, if you click animate here, here's the animation. So this is the animation that we saw before. We'll go ahead and stop animation. Let's look at the code. If we are looking down here, you should already have an idea of how these relate to each other at this point. So I'm just going to quickly go through. I'm not going to explain this as much. So there's a move. If we look at move here, this kind of works in the same way. It just moves the frame up 20 pixels. So it's not as fluid as setting velocity. Velocity is when, you know, you're walking and there's a constant motion, not like just a quick jump. That's why it looks a little rigid, you know. And I'm going to keep this here because you're kind of moving him forward 20 pixels. You're kind of moving him forward 20 pixels to simulate the step. He's a big guy, so you know he's moving forward, and at this point he is starting to step forward. That's why he's applying a 20 to this particular frame. So he's moving forward like 20 pixels. And then when you see that leg step down, he's now moved 50 pixels instead of 20. So from his beginning spot, he's 50 pixels ahead now because of his foot placement. So this foot here, he's ahead 50. So I'm actually going to keep all this, to be completely honest. But what I want to also happen is after he plants his foot, let me go back here to see where he actually plants his foot. So he has, okay. So he's starting up his punch. All right. At this point, you see where he plants his foot. This is where I want him to start moving a little bit. So he plants his foot, then he goes forward. So this is definitely all right. So I want him to, so at this point, move forward a little bit. I'm gonna have him go at a velocity of maybe 4, maybe 2 or 3. We'll check and see. We'll start with 3. So here, start with a velocity of 3, maybe 2. Velocity of 2 until he gets to maybe this point, to slow it down a little bit, and then maybe here we can stop him. So at frame 15 we stop. At frame 12 we bring him down to velocity 1. Frame can't see, frame 7 will start his velocity at 2. And what will happen is when I started at 2 here, so it's going to start right here. What will happen is each frame up until I change the velocity is going to move forward 2 pixels, but it's going to be very smooth, as you're going to see. It's not going to look choppy. So we're at frame 7. And remember, to start anything at a certain frame, you put the code above it. So we're going to do command, ampersand command, say move X. Remember, move X only has 1 parameter, so your parameters are shown and denoted by or delimited by spaces. So after move X, after the space after move X, we're just going to put a 2 to access the parameter. So he's going to move forward, and then I think we said 12. We're going to bring it down to 1. So we're going to do the same thing. Ampersand command, move X down to 1. And then we said at 15, we're going to stop. So let's do ampersand command and then stop. Stop did not have a parameter. We're going to save this, but we don't have access to these animations or these functions yet. We need to actually make sure that the animations have access to the function. And the way to do that is go back to your character details page. We know the location of where it is data, scripts, animation.c. So we need to type in animation script. That is the animation script that will apply to this particular model. And this script, is this scripts or script? We got that fast. Yeah, scripts. This script is located in data scripts animation/animation.c. Okay, so now we're going to save and we're going to try to run and see what happens. It might look a little weird, so we'll see. So it ran, not having any issues because players are loaded up at the very beginning. So if there was an issue, this game would not have opened. So let's go to, all right. See what happens. Woo. Okay. One thing I just noticed. Move X applies X to both X and the Z axis. So that's why this is looking weird. So this is more of a twirly movement than a straight left and right. But that is easily fixable. All we got to do is use the dasher function instead. I explained that incorrect. So now you can see what happens when we're reading through this. Sometimes you think you have an idea of how it's working, but then when you see it in the game, you can see that, oh yeah, no, it's moving differently. And then you can make decisions based on what you've been able to find and what you have access to. So I wanted you to see that. Dasher, though, allows you to control the 3 different access values. So if we go back, in our case, we are going back to free special, and we are going to change some things. So we're going to change move X to dasher, to dasher 200, because 2 represents the X axis, 0 represents the Y axis, 0 represents the Z axis. So 200, Then we're going to change this to Dasher 100. We only want to affect the x-axis. Open this up again. Go ahead and go to water level. Max. He's ready. See, now you can see. There it is. He's moving straight ahead. And he stops. So it looks very fluid, as you can see. So yeah, so that's how you do it, man. And he moves forward. I'm gonna take her out. Take her out. All right, cool. So we'll leave it at this. But yeah, that's how you add different functions and do some additional scripting to make your models a lot more fluid. There are a lot of different scripts out there on ChronoCrash as well. Many people have written some script libraries that's already been done, so you don't have to reinvent the wheel. But this shows you how to take those scripts and actually run them for whatever you're trying to do. Again, I wanted to make them smoothly dash forward a little bit instead of that little step forward that he was doing. So we were able to do it. So hopefully you learned something from this and definitely apply it on your own in ways that you can think of. But again, I appreciate you guys for watching. Again, this is Kevin. Hope you stay blessed and stay brilliant. Peace. We hope you're learning what you can from these free tutorials. Again, if you feel you need more in-depth or extensive services or extra help with learning and getting the most out of this and don't want to wait on the videos, please feel free to join our DBH community for only $5. That doesn't mean you can't ask questions on here though. So if you have any comments or questions, please feel free to post those. Like and share this playlist for those who may need it. At the end of the day, we just want to help people build their engineering and coding skills to be efficient wherever they want to go. I'm Kevin. Appreciate you watching and be brilliant. Peace.